rational exponents. Alright, the first example, these are three different parts to the first example. You're going to be given something in exponential form and have to convert it to rational form. You'll be given something in, radical form. You'll be given something in radical form, have to convert it back to exponential form. The first example, 125 to the 1/3 is exponential form. To convert that to radical form, it would be right here. The denominator of the fraction is the root when you change it to radical form.
So if that were like 1/7th,
It'd be
it would be
7
Seventh
root
root.
125.
Yes. And we know that the cube root of 125 simplifies to 5.
What if
Yes.
So if it was a 2, it would just be square root?
Yeah, that's what we're doing here. There are a couple ways you could do this one. You could change both of these to square roots. Square root 5 times square root 5. Anytime you multiply a radical by itself, it's just 5. What I did, if you're multiplying two numbers with the same base, what do you do to their exponents?
Add.
Add them. So what's 1/2 plus a half?
1.
1. So this becomes 5 to the 1, which is 5. So you can do it either way. Down here, you could do this a couple of ways. The way I did, I changed the 100 to 10 squared. And 10 squared to the 1/3 is 10 to the 2/3. You see how I went from this number to this number?
No.
100 is the same thing as 10 squared.
Yeah.
So let me throw that step in there. So 10 squared to the 1/3 is 10 to the 2/3. I rewrote the 100 to the 1/3 as 10 squared to the 1/3, which is 10 to the 2/3. So once the bases are the same, you do the same thing we did up here. Add the exponents. 1/3 plus 2/3 is 1, so 10 to the first is 10.
What if the top were like 125 and 2/3?
125 to the 2/3.
How do you do
I
that?
think we get into that next. But
Okay.
what you would do is cube root of 125 squared.
Oh,
So
okay.
we'll just square this to get 25. But I think that's in the next example. Yes.
So every time you multiply a radical by itself, it's always the radical?
When you yes. When
Okay.
you multiply a radical by itself, a square root by itself. Square root 5 times square root 5 is just 5.
Okay, can we
Not any radical, that's just for square roots.
Okay.
Okay, but Remy, your question, yeah, all of these had 1 as the numerator.
Yeah.
If the numerator is something other than 1, then you have to raise it to that power. Okay, let's look at the next example. So yes, this is what you were just talking about. Converting to radical form. X to the 3/5 in exponential converts to the 5th root of x cubed. It does not matter where that cube goes, just like we talked about in the first example. We could put this whole thing in parentheses and then cube it. Sometimes it's easier to cube this number first. Sometimes it's easier to take the 5th root of the number first.
So it can be the numerator or denominator outside?
No. No, it has to be the denominator as your root number. Alright, so in the second example, there are two things wrong with this. You can't have a negative exponent. You learned that back in Algebra 1. To get rid of a negative exponent, you just take the reciprocal to make it positive. Then change the decimal to a fraction, and then I can put it in radical form. Okay? Y to the 5/2 is the same thing as square root of y to the 5th.
Oh, that's not, is that, so
Anything to the 1/2 power is the same as square root. You don't have to put a 2 out here. 2 is understood for square roots. Okay?
you always have to turn it into a fraction?
If it's a decimal, change to a fraction. Yeah, that's the only way you can get to radical form. Alright. Next. There will be a calculator part and a non-calculator part on the test. You're going to have to do this type of problem without the use of a calculator. And the way we do that is to first convert it to radical form. So make sure you understand how I went from here to here. I take the fifth root of negative 32. This is what I was talking about earlier. We could either cube this negative 32 or cube the result of the fifth root of negative 32. It'd be a lot easier to take the fifth root of negative 32, which is what? Negative 2. You should be able to figure that out on your own. And then cube that number to get negative 8. That'd be easier than cubing negative 32. Okay? You probably couldn't figure that out as quick. And then taking the fifth root of that result. Okay? Same thing here. 4 to the negative 3.5 becomes 1 over 4 to the 7 halves, which is 1 over the square root of 4 to the 7th. The square root of 4 is what? 2 to the 7th is 128. Okay? Got it? And the last example. Simplify. Let me see something. Okay. So this is the last example. Simplify 16y to the negative 8 raised to the negative 3/4. We got to raise both numbers inside the parentheses to the negative 3/4 power, which I did here. When you raise a power to a power, what do you do to the exponents? Multiply. So negative 8 times negative 3/4 becomes 6, positive 6. Okay? Now that's fine. We're good right here, but we need to simplify this. Make the exponent positive by taking it down to the bottom and changing it to radical form. 4th root of 16 cubed. 4th root of 16 is? 8. 2 cubed is 8. So there's your final answer. Good?
So what's the 4th root of 16 again?
4th root of 16 is 2. Alright. I'm going to give you some sample problems. Alright. Try those.